MariaDB at the edge and loving it. I'm Daniel Black, I'm from the MariaDB Foundation, and I'm here to talk about how MariaDB goes on the edge. So a little bit about MariaDB. It's open source, and it's been open source at GPL v2 since it forked from MySQL many years ago. It remains cross-platform on Linux, Windows, AIX, FreeBSD, OpenBSD, OS X, OpenSolaris, to name a few that are supported by us. And there's also a number of hardware variants from your x86 to your ARMs to IBM Powers and S390s, and distro support a number of other variants as well. So when we talk about what's normally considered a database infrastructure, we normally actually think of a big monolithic database in the center where everything connects in, which is about as opposite to the edge as you could get. However, in the MariaDB development, we went through a transitional phase towards the cloud at the start, and that at least entered the monolith. It's amazing what you can do when you don't have per licensing costs on it. And now we can have a number of different MariaDB instances, some small, some large, depending on the application. And this was a good intermediate step as far as the technology went, from the monolith of the center to the edge. And so when we talk about what edge database requirements exist, to take this roughly from Wikipedia, it's talking about the privacy, the security, the scalability, the reliability, the speed, and the efficiency. So when we talk about privacy and security in the MariaDB sense, we've had data at rest encryption for quite a few years, and that's supported by a number of plugins. And being an open architecture, there's a plugin API to write your own data at rest encryption. So this is all the table spaces, the binary logs, and a number of different aspects of the server is encrypted at rest. There's TLS encryption between the client and server, and that's been there since the early MySQL days, as has some of the async server-to-server encryption. Galera, obviously a MariaDB only feature, is there on TLS as well as an option. Also, if you're using like the S3 storage engine, that actually connects over HTTPS, so you've got the privacy covered on that aspect. When we talk about the hardware in which MariaDB can run, we can talk about really low-end computing, i.e. 500 megs of RAM, and people still do run it on that. But there's also, you can scale up to the high end, and when I was at IBM, running on 250 gigs to 1 terabyte RAM for testing was quite possible as well. So we've got a wide range of hardware. And because there's so much hardware, it doesn't actually matter if in a replication scenario, if the master is a really large server or a really small server, they can be different configurations throughout that. We can also configure from a little Indian Edge ARM machine all the way to a big Indian S390 machine. Within the server itself, most of the settings related to resource, including the RAM settings of, say, energy, buffer pool, the number of connections, the I/O characteristics on flushing are dynamic and can be changed at runtime. As I'll cover towards the end, we're moving towards having more of these settings auto-scaled and responding to event pressures in the edge environment. More on that later. If we look at like the architectures MariaDB can exist in an edge, we've got a fan-out approach, i.e. say a master in a central data center, replicating out to MariaDB edge nodes for read access on the replicas of the edge. We've got a multi-source available, so whether you consider like the two masters as like two edge nodes collecting data and feeding the back into a replica at the back end for aggregation, or flip the architecture and have two different data sources in various parts of the infrastructure replicating out to read nodes at the edge. I mean, both scenarios actually work on multi-source replication. What we've had for a couple of years is the Spider storage engine, which makes a table that's local or that is remote appear as if it's local. It also has advanced scenarios that the remote one can be redundant in various ways, and so that sort of opens up the opportunities for failover in that way. It also can be like sharded, that one table on a local node can actually be distributed across a number of different backends, and this kind of makes sense if the data is partitioned in such a way that there's sensors at different locations, but you want to look at it if it's like an entire table, and query optimizations are built into that, so it makes it a distributed kind of processing system. And obviously there's a bit about that these can be combined into highly available backends as well, using like two-phase commits and that kind of thing. So not only the nodes remote, they can be updated locally. Galera is another scalable architecture where all the nodes sort of talk and replicate to each other, and you can read and write it at any node to get your data through and to update that. And all the nodes are a full replica, so the access is still local. We talk about edge nodes, that edge nodes can go down, so the reliability aspect needs to be there if a node's down. On the client side, we can have like a JDBC connector that specifies the number of hosts where it goes to, and listing them in a failover order as to what's closest, but having fallbacks exist. There's also avenues for using proxy-based failover between nodes, and that's like in the max scale. HA proxy, a TCP proxy, like Nginx or whatever, and that can exist in the infrastructure as well. What goes on with reliability, if we talk about node recovery in Galera, we've got a quorum-based state of the network communicated amongst each node, so each node can actually go down at any time, provided there is a majority of the nodes still running. It'll declare itself as primary and operate to the fullest extent possible with that. And this is just a split brain recovering that we see in clustered systems all the time. When a node goes down and sort of comes back, there's a state mechanism to bring the node back to its full state. And whether that's just catching up a few rows, or we need the entire copy of the database sent over, there's scriptable ways to recover the node and a number of built-in mechanisms. So what we end when we recover back, we've still got a full copy of the database at each node. We've got notification of events as nodes go down or up or come back to be sent back, so we can sort of integrate with other proxies and keep alive mechanisms to ensure that notification of the Galera cluster is communicated. So when we look at like the efficiency of what edge node gets in, if we've got like a replication fan out scenario, that means that the edge nodes that are querying the data aren't querying all the way back to the back end. They're just retrieving data if it's locally, and all this corresponds to less bandwidth, but it also corresponds to a greater speed because we've got lower latency. As it's an SQL server, the speed's also there in the way that SQL is implemented on the hood to give you the data you request for in the quickest way possible. And that happens regardless of whether it's in Edge or not. So where to next? Well, in the MariaDB Foundation, a Kubernetes operator is in development. We're moving towards more dynamically sized variables that can be changed and resized at runtime. We're looking at event-driven, and things like the Linux kernel will tell you if, I'm a bit short on memory or a bit short on CPU, and that kind of tension is being applied to the system. And what this events give us is the opportunity to be a little bit polite towards the neighbours in the edge nodes on things we may not need to do immediately, flushing or whatever. So we've got the ability to release memory that maybe it's a cache that we haven't used for 10 minutes. If that memory can be released, it's better as a edge node citizen to be cooperative with the operating system at the time. Also looking at getting a serverless kind of approach, and that sort of scales down to zero. So the MariaDB kind of stops if it's not being used, and it'll rely on socket activations or an aspect within the Kubernetes to bring itself up in a really quick way. So these are all the ways that MariaDB is working to be the best node citizen that it can. Thank you for your time, and enjoy your OpenNebulaCon. Bye.